Rahim. Now we're going to continue our statics revision, equilibrium of a body on a rough inclined plane. You have an example. A body of weight 8 Newton is placed on a rough plane inclined at 30 degrees to horizontal such that the body is about to slide downwards the plane. If the body is pulled by a force P parallel to the plane upwards and makes an angle of measure 30 aboard the plane, such that the body is about to move aboard this plane. Find the magnitude of the normal reaction force. Okay, here we have two cases. First one, when the body is placed on this rough inclined plane and theta here is 30 degrees, okay, and W is 8 Newton. In this case, the body is about to slide down towards the plane, okay? As the body is acted upon by its weight only, then here mu s equals tan theta, okay, equals 1 over root 3. Okay, this is first case. Okay, second case, when the body is pulled by an external acting force P in this direction, makes an angle of measure theta to this horizontal, okay, this inclined plane, okay, not horizontal, to the inclined plane here theta, in this direction, such that the body is about to move aboard the plane. Then here the expected motion direction in second case is aboard the plane. This is required to find the normal reaction force. Okay, for second case we have to apply the steps of solution. We have x and y, x in direction of this inclined plane and y in direction perpendicular to this direction. Okay, second is the force acting upon this body, of course B, and here we have W, W cosine theta, and in this direction second component W sine theta. Okay, we have here normal reaction which is required to find. Okay, also the expected motion direction in this direction. Then we have in opposite direction, in this direction we have limiting friction force as the body is about to move. Then we have here mu s times n. Okay, and now we have to resolve also this force in two signal direction, in direction of x and y. Then we have here P cosine theta, and in this direction B sine theta. And finally we have to apply equations of equilibrium as the body is about to move. Then there is an equilibrium status in this case. Okay, then we have summation of x equals 0. The sum of the component of the forces parallel to the inclined plane equals 0. The expected motion direction is aboard the plane. Then we'll start with this component. We have P cosine theta, okay, equals W sine theta plus mu s times n, and this equation number 1. Also we have summation of y equals 0. We have n plus P sine theta equals W cosine theta. Then we have n equals W cosine theta minus B sine theta, and this is equation number 2. Okay, then we can substitute from 2 to 1. Then we have B cosine theta equals W sine theta plus mu s W cosine theta minus mu s B sine theta. Then we can take B as common. We have cosine theta plus here mu s sine theta. Okay, this is equals W as common, sine theta plus mu s cosine theta. Then B equals W sine theta plus mu s cosine theta divided by cosine theta plus mu s sine theta. We can substitute by figures. Then we have here W is 8, sine theta, theta is 30. Then we have half plus mu s is 1 over root 3 as we found from this first case. Okay, times cosine 30, we have root 3 over 2 divided by cosine 30, we have root 3 over 2 plus mu s 1 over root 3. okay, times sine theta is half. Here then B equals 4 root 3 Newton, and this is the first step. To find the normal reaction of this inclined plane to this body, we can substitute in equation number 2, for example. Okay, then we have N equals W is 8 cosine 30 is root 3 over 2, k minus b, who found before, root 3 times half, k sine 30. Then we have here in normal reaction force equals 2 root 3 Newton, and this is required to find. I have another example. In this figure, the body is placed on this rough inclined plane. Inclination angle is theta, and acted upon by this external force P parallel to this inclined plane and acts in upwards direction like this. Okay, if the weight of the body is 25 Newton, when P equals 15 Newton, the body is about to move upward the plane. Okay, when B equals 10, then the body is about to move downward the plane. Find the static friction force. Okay, here we have two situations. For first case, when B, we have this body and we have here theta. When B equals 15 Newton, okay, then the expected motion direction is upward the plane. Okay, we'll assume x and y as usual in direction of this inclined plane x, and here we have y. Okay, the forces acting upon this body, we have its weight here, this component 25 cosine theta, and we have here 25 sine theta. We have this external force P equals 15 Newton, and we have this normal reaction N. Okay, also we have the friction force in opposite direction to this expected motion direction. In this direction we have Fs. Okay, again we have to apply the equations of equilibrium. In this case, summation of x equals 0. Then we have here 15 equals 25 sine theta, okay, plus Fs, and this is equation number 1. We have also n equals 25 cosine theta, and this is equation number 2. This is first case. Okay, for second case we have the same situation here. We have here theta and we have this body. Okay, and here P equals 10 Newton. In this case, expected motion direction is downward the plane. Then if we identify the forces acting upon this body, we have here 25 cosine theta. Here we have 25 sine theta, and we have this normal in reaction, in this case normal 2. Okay, also the expected motion direction is downward the plane. Then in opposite direction, in this direction we have Fs. Okay, also Fs in this case is mu s n2. Okay, and as we have now we have to apply equations of equilibrium. Okay, as it's clear that if we start with the summation of phi equals 0, we have here n2 equals 25 cosine theta. This is equals n1, okay, or n in this case. Okay, then we can also apply summation of x equals 0. Here we have 25 sine theta equals 10, this plus mu plus Fs, as Fs in this case equal Fs in first case, as both are mu s the times n, and n is 25 cosine theta. Okay, then Fs here is Fs here in first case. Okay, then we can find that 10 equals 25 sine theta minus Fs. Okay, now we can subtract. This is equation, for example, number this 3 and this is 4. Okay, we can subtract equation number 1 minus equation number 4. Okay, then we have here 5 equals this will cancel with this, and we have here 2 Fs. Okay, Then friction force here, Fs, as is it's static friction force, as a system is about to body is about to move downwards or upwards. Then Fs, limiting friction force, equals 2.5 Newton, and this is required to find. We have another example. A body of weight 80 Newton is placed on a rough inclined plane, inclined at theta to the horizontal, where tan theta equals 3/4. The body is acted upon by horizontal force B of magnitude 160 Newton, such that the body is about to move aboard the plane. Find mu s, the static friction coefficient between this body and this inclined plane. Okay, here we have this body of weight W equals 80 Newton. Okay, placed on this inclined plane, inclination angle theta, where tan theta equals 3/4. Then this side is 5. Okay, the body is acted upon by this horizontal force P. This direction equals 160 Newton. It's required such that the body is about to move aboard the plane. The expected motion direction is aboard the plane. Then it's required to find the static coefficient, friction coefficient between this body and this rough inclined plane. Okay, here we'll assume x and y in this direction. X and this direction is y. Okay, the forces acting upon this body is its weight component is W, 8 cosine 30. Okay, or for example we'll assume it W for simplicity, and then finally we'll substitute by figures. W cosine theta. Okay, here we have W sine theta. We have this normal reaction force. Okay, and as expected motion direction aboard the plane, then we have here this limiting friction force mu s times n in this direction. Now it's time to resolve this force into two orthogonal components in this direction, okay, and in this direction. Okay, as we have this force is horizontal parallel to this one, and here we have theta, then we have B cosine theta, and this direction B sine theta. Okay, now it's time to apply the equations of equilibrium. Okay, summation of x equals 0. The sum of the force component in the direction parallel to this inclined plane equals 0, as expected motion direction in this direction will start with B cosine theta. Then we have B cosine theta equals W sine theta plus mu s times n, and this is equation number 1. We have also summation of phi equals 0. Here we have n equals in this direction W cosine theta plus B sine theta. Okay, this is equation number 2. We'll substitute from 2 in 1. Okay, then we have B cosine theta equals W sine theta plus mu s times n. You have n here, W cosine theta plus B sine theta. Okay, then now we can substitute by figures. Then we have P is 160 cosine theta. Here we have cosine theta is 4/5. 4/5 equals W is 80. Sine theta is 3/5. Okay, plus mu s is required to find. W is 80. Cosine theta is 4/5 plus B 160. Sine theta is 3/5. Then from this equation we can find mu s. Simply mu s equals half, and this is required to find. Another example. In this example we have this system consists of this body number 1 placed on this rough inclined plane with inclination angle to horizontal equal theta equals 30. The weight of this body is 5 Newton. Is connected by a rope passing through this smooth body to another body, suspended body, body number 2 of weight 6 Newton. The system is in equilibrium. It's required to find the magnitude and direction of the friction force. Okay, solution. First, we have to assume x and y direction as usual. Here we have x direction and y direction. Okay, and we have to find the forces acting upon each of these two for this body. Okay, here for this suspended body we have W2 2 in this vertical downwards direction. We have here tension, and we have also here the same tension as it's the same wire. Okay, here we have W1 cosine theta, and this component W1 sine theta, and we have here normal reaction of this inclined plane on this body. Okay, now we have to apply the equilibrium equation on this body and on this body. For suspended body, body number 2, okay, we have summation of x equals 0, but we don't have any horizontal forces acting upon this suspended body, but we have in this vertical direction summation of y equals 0. Then we have t equals w2 equals 6 newton. Okay, this first step. Now we can apply the same equilibrium equation of body number 1, which is placed on this rough inclined plane. Okay, we have here first we have to find the friction force. Okay, to find the friction force, we need to find the expected motion direction. Okay, for this body placed on this rough inclined plane, we compare the magnitude of the forces acting in this direction to the magnitude of this forces acting downwards the plane. Okay, then we have here T equals 6 Newton. This is number 1. We have W1 sine theta, and we have W1 is 5 sine 30. Then this equals 5 over 2 Newton. Then it's clear that T is greater than W1 sine theta. Then the expected motion direction of this body is upward the direction like this, and the suspended body will move downwards like this. Okay, then we have in opposite direction to this expected motion direction of body number 1, we have here F friction force. Now we can apply the equation of equilibrium of this body number 1. Summation of x equals 0. Then we have T equals F plus W1 sine theta. Okay, and we have summation of y equals 0 also for this body placed on this rough inclined plane. We have n equals W1 cosine theta. Okay, it's required to find f. From this equation we can find f equals t minus W1 sine theta. Then we have t equals 6 minus W1 is 5, sine theta is half. Then we have f is 3.5 Newton, and its direction is downward is inclined plane in direction of W1 sine theta. Another example in the figure, the plane is rough, the body is about to move aboard the plane. Find tan theta plus mu s, where mu s is the static friction coefficient between this body placed on this rough inclined plane and this inclined plane. The inclined plane is inclined at theta to horizontal, and the body of weight W, and the body is acted upon by this this force parallel to the inclined plane upwards, and B equals W. Okay, here we can assume x and y direction, this x and this y direction. We have here to find the forces acting upon this body. You have here W, we resolve it into two signal direction x and y. Then we have here W cosine theta, and we have here W sine theta, and we have B, we have also this normal reaction force. Okay, the expected motion direction is in this direction. Then in opposite direction, this direction, we have limiting friction force as the body is about to move aboard the plane. Then we have mu s times n here. Finally, we have to apply equations of equilibrium for this body. We have summation of x equals 0. The sum of the component of forces acting on this body parallel to this inclined plane equals 0. Then we have B equals W sine theta plus mu s times n. This is equation number 1. We have summation of y equals 0. Then we have n equals W cosine theta. This is equation number 2. Can substitute here. Then B equals W sine theta plus mu s W cosine theta. Okay, here we have B equals W sine theta. plus mu SW cosine theta. We'll divide all terms by W. Then we have 1 equals sine theta plus mu S cosine theta. Okay, we'll divide by cosine theta. Okay, then we have here 1 over cosine theta equals here 10 theta plus mu S. Then it's required to find the value of magnitude 10 theta plus mu S. Okay, this is equals sec here 6 theta. Okay, 1 over cosine. Okay, and this is required to find.